Hello, we're going to be working problems out of Chapter 5, Halliday and Resonance on Forces in Motion. The first problem will be problem 23. Tarzan, who weighs 820 newtons, swings from a cliff at the end of a 20-meter vine that hangs from a high tree limb and initially makes an angle of 22 degrees with the vertical. Assume that the x-axis extends horizontally away from the cliff edge and a y-axis extends upward. Immediately after Tarzan steps off the cliff, the tension in the vine is 760 newtons. Just then, what are A, the forces on him from the vine in unit vector notation, and the net force on him in unit vector notation, and as a magnitude and angle relative to the positive direction of the x-axis, what are the magnitudes and angles of Tarzan acceleration just then? A lot of questions, so we'll just take one at a time. First, we'll just draw this situation with the vine and Tarzan on this cliff. Holding on to a vine. And he's going to swing to another cliff. And he has an angle of 22 degrees. So the forces on him from the vine in unit vector notation. Now, when he steps off, the forces from the vine is 760 newtons. So we could complete a vector triangle like this. This is in the x direction. And this would be in the y direction. If this is 22 degrees, this vector here would be, we'll just call this f of x, and it's going to equal 760 times the sine of 22 degrees, and that's going to equal 284 newtons I hat. So f of y, which is this vector here, is going to equal 760 times the cosine of 22 degrees, and that's going to equal 705 newtons J hat. So that would be expressed as F equals 284 I hat plus 705 J hat newtons. So B asks for it in unit vector notations. So we're going to draw another little sketch for B. Here's the vine. Here's Tarzan. We're just going to make him a little ball since I'm not doing too good with my stick diagrams. And he is 820 newtons. That's his weight. And we have a vector opposite caused by the vine of, and this will be a cosine function of 760 times the cosine of 22 degrees. So what we have here is 820 newtons minus 760 cosine 22 degrees, and that's going to equal 115 newtons J hat. So for B, we will write 284 hasn't changed in the I hat direction. So F in this case is going to be 284 I hat plus 115 J hat. Now we see that this 820 is larger than the 760 cosine of 22, so the direction is negative. So that's going to be minus 115 J hat. So that's B. And C is magnitude. So magnitude, the way we always do it, we're just going to say F, this is C, it's going to be absolute value (284) square plus a minus 115 square, and that's going to equal 306 newtons. And D, the angle, well, we know theta tan to the minus 1, a minus 115 divided by 284, and that's going to equal a minus 22 degrees. And E is the magnitude, and F the angle of Tarzan's acceleration just then, just as he stepped off the cliff. So E, we know that F equals MA, which goes to A, acceleration, is going to equal F over M, which is equal, we have the force. The force is 306 newtons. And we have his weight, which is 820 newtons, which you have to divide by 9.8 meters per second squared in order to get that in mass. So this will equal 3.67 meters per second square. And finally, Tarzan, the angle of Tarzan acceleration just when he steps off. And it's going to be the same as D, but let me just show you something here. It's going to be, it's just below the cliff. And I know this is more than, but we're just going to say this is 22 degrees, and it's going to be tangent to this arc that he'll make when he swings to the other cliff. 22 degrees, just below the cliff horizon. And so the angle must be in the same direction as the acceleration. So this is also going to be minus 22 degrees.